Okay. Hi, everyone. I am just going to go over all these questions so you can watch it along with looking at the answer key so you know how to do all the work for the balancing equations, okay? So that you can use it for the quiz on Tuesday and Wednesday for D and G period. Okay, so here's the first reaction. Remember, I require to see all the work that you need to do for every single equation. So I need to see the columns and all of that. Okay. So inside the columns, I'm going to write zinc here. That's my first element. Then I have hydrogen and I have chlorine. And then I'm going to count. I have one zinc, I have one hydrogen, and I have one chlorine. I have one zinc, I have two chlorines based on the subscript, and I have two hydrogens. You'll notice right away that hydrogen and chlorine are not balanced, which means I can balance both hydrogen and chlorine with one number because hydrogen and chlorine are together on the reactant side. So in order to get hydrogen and chlorine to be 2, I put a 2 there. 2 times the hydrogen and 2 times the Cl changes that to 2 for both of them. So that's balanced. Then the next one is here. Let me scroll down a little bit. Right there, you have inside the column, I'm going to write aluminum. Again, I have H and Cl together. This is a very common thing that you'll see happening because hydrochloric acid is a very common reactant, as I told you before. Okay, so I have one aluminum, one hydrogen, one chlorine. Ooh, meant to write a number there. One chlorine, and of course, as you know, we have a kind of a glitchy smartboard situation here. So let me move it down again. It's no different from being in class, right? Okay. Okay, so that should fix it. So I have one chlorine, that's where I was, and then I have one aluminum, I have three chlorines and two hydrogens. This is a pattern you'll see quite often, this 2 and 3. If I put a 2 or a 3 here, I can't balance both the hydrogen and the chlorine, so I have to find a number that's common to 2 and 3, which is going to be 6. So 6 and 6 for both hydrogen and chlorine. And now I can balance my products. If I want to make this 3 chlorines into a 6, I have to put a 2 there. That gives me 2 times 3, 6 chlorines. And if I put a 3 here, that gives me 3 times 2, 6 hydrogen. So now hydrogen and chlorine are balanced, but this 2 now made the aluminum into a 2, which means I have to put a 2 here, and that becomes 2. And we're balanced, okay? Then the next one is number 3 right here. Scroll down. Okay. The cursor should prevent the document from jumping around. That's why I try to select it there. Okay, so reactants and products. Inside I have magnesium, I have hydrogen, I have phosphorus, and I am going to count one magnesium. I have 3 hydrogen and I have 1 phosphorus. Here I have 3 magnesium, 2 phosphorus, and 2 hydrogen. Okay, so here's what I was talking about, this 3 and 2 pattern. Okay, in order to balance a 3 and 2, if 3 is on one side and 2 is on the other side, we're looking for a common number, which is 6. So in order to balance hydrogen here, I need to multiply this 3 by a number that makes it 6, which is going to be 2. 2 times 3 gives me 6 here. And let me balance here as well. If I put a 3 there, 3 times 2 gives me 6. Now putting a 2 here also made the phosphorus into a 2, that made phosphorus balance out. I have 3 magnesiums on the product side, which means I have to put a 3 there. 3 times the Mg gives me 3 there. 362, 362, and we are balanced there. Okay? Then, let me go down. All right. Move the cursor there. We have reactants, products, column, I'm going to write calcium, Pb, and Cl. So calcium, lead, and chlorine. I have 1, 1, and 2 chlorines. I have 1 lead, 1 calcium, and 2 chlorines. This reaction is already balanced. No work is required. Sometimes this happens in chemical reactions where everything is already balanced, so you don't have to do anything, okay? Then the next one, you have reactants, products, column, Al, Pb, and F. Let me count. I have 1 aluminum, 1 lead, and 2 fluorines. And I have 1 lead, 1 aluminum, and 3 fluorines. Again, 3 and 2 pattern, we're looking for a 6. So in order to get this 3 up to a 6, I must multiply this compound by 2. 2 times 3 gives me 6. I have to multiply this compound by 3. 3 times 2 gives me 6. Now let's see what I did to the rest of it. I made the aluminum a 2 here, and I made the lead a 3 here. So in order to balance the aluminum, I must put a 2 over here. That gives me 2 there, and I have to put a 3 over here. That gives me 3 there. 2, 3, 6, 2, 3, 6, we're balanced. Then the next one is over here, number 6. Okay, I have reactants and products. Inside, I have zinc, I have SN, which is actually tin, and I have bromine. Let's use gray. I have 1 zinc, 1 tin, and 4 bromines. I have 1 zinc, 2 bromines, and 1 tin. So seemingly bromine is the only thing that's not balanced, so I gotta put a 2 there to balance the bromine. 2 times 2 gives me 4. That changed my zinc to 2, which means I have to put a 2 here for the zinc. Change that to 2, 2, 1, 4, 2, 1, 4, and we are balanced. Then the next one, reactants, products. I have Cl, aluminum, and iodine. That's Ali3 is what you're looking at there, okay? I have 2 chlorines, I have 1 aluminum and 3 iodines, and I have 1 aluminum, 3 chlorines, and 2 iodines, right? Okay, again, you'll notice there's a 3 and 2 pattern here, and also a 3 and 2 pattern in the chlorine. So you know that chlorine and iodine both have to be 6. So let's try to get 6. If I put a 3 here, 3 times 2 gives me 6 there. If I put a 2 here, 2 times 3 gives me 6 there. But that changed my aluminum over here to 2, okay? But we'll deal with that in a second. If I put a 3 here for iodine, that gives me 6 there, because 3 times 2 gives me 6. If I put a 2 here, that gives me 6 there, and I ended up fixing my aluminum. 2 birds, 1 stone. 6, 2, 6, 6, 2, 6, and we're balanced. All right, let's do this one. This one seems to have like a lot of elements, okay? So I think there's like 5 in total or something. So I have nitrogen, I have hydrogen, I have iron, I have chlorine. Oh, I missed iodine. I have iodine. Oops. Didn't mean to do that. Let me go down. Okay. It just goes back to basically the previous problem where there's the cursor. There we go, we got it. So I have iodine, I have iron, and I have chlorine. So let's count. I have 1 nitrogen, 4 hydrogens, 1 iodine, 1 iron, and 3 chlorines. I have 1 nitrogen, 4 hydrogens, 1 chlorine, 1 iron, and 3 iodines. So seemingly chlorine and iodine is again what's not balanced. So let's balance that. If I have 3 iodines on the product side, I got to put a 3 here to make this iodine a 3. That changes the nitrogen to 3. And 3 times 4, that actually changes the hydrogen to 12. Let's see, if I have 3 chlorines on the reactant side here, I got to make that 3. So I'm going to put a 3 there. That changes that to 3. That helps me balance my nitrogen now, and then also my hydrogen, which is now 12. Okay, 3, 12, 3, 1, 3, and we're balanced. Don't forget, there we go. Reactants, products, K, Br, Pb, Cl. K is potassium. I have 1 potassium, 1 bromine, 1 lead, 2 chlorine. I have 1 potassium, 1 chlorine, 1 lead, 2 bromine. So chlorine and bromine not balanced. Got to put a 2 there. Makes potassium and bromine 2. Got to put a 2 there. Makes potassium and chlorine 2. 2, 2, 1, 2, 2, 2, 1, 2, and we're balanced. And now, one before last. Reactants, products. I have aluminum, chlorine, hydrogen, and sulfur. Okay, I have 1 aluminum, 3 chlorine, 2 hydrogen, and 1 sulfur. I have 2 aluminums, 3 sulfurs, 1 hydrogen, and 1 chlorine. Okay, I see a 3-2 pattern or 2-3 pattern, but it is on one side. But since hydrogen and chlorine are together on the other side, that means I should be able to balance this 1 and 1 with the same number. The same number that is common to 3 and 2 is 6. So I got to put a 6 there. That changes both of them to 6. Okay? So that means I have to make this 3. I have to put a 2 in front of that compound. 2 times 3 gives me 6. That changed my aluminum number to 2. Nice, that balanced the aluminum. And in order to make the hydrogen a 6, I have to put a 3 in front of there. 3 times 2 gives me 6 there. That also changed my sulfur to 3, and that balanced my sulfur. So fixing the pattern or balancing the pattern actually helps us balance the entire equation, which is really nice. It's kind of like self-balancing when you balance the pattern. All right, last one. You have reactants, you have products. Okay, so I have aluminum and oxygen and the barium and chlorine. What's the color I haven't used? Pretty purple. Okay. I have 2 aluminums, 3 oxygens, 1 barium, and 2 chlorine. I have 1 barium, 1 oxygen, 1 aluminum, and 3 chlorines. Whoa, 3-2 pattern. Again, what? Okay, so we're looking for a 6. 2 must become a 6, so I have to put a 3 in front of the BaCl2. That makes it a 6. Changes the barium to 3. I must make this 3 over here into a 6, so I got to put a 2 there. 2 times the 3 gives me 6 there. Then 2 aluminums. Aluminum is balanced. Oxygen and barium are not balanced here and there. But look, on this side, barium and oxygen are together, and it's 1 and 1, which means if I put a 3 there, that changes both of them to 3 and 3, 2, 3, 3, 6, 2, 3, 6, 3, 6, and we're balanced. All done.